Okay, so we've looked at a couple of things, the overview, what's in the case kind of deal, how you would unplug and plug back in. Chapter 2 is actually to take out a motherboard. You'll do that, and we're going to talk about motherboards and the components that are on them today. What we want to do is the objectives, learn about the different types and features of motherboards. Features, what it does. You guys with the gaming stuff, there's lots of features on those. Us ordinary people don't have so many because we don't need so many. When you start working in a company, you're not going to have the high-powered gaming stuff. You're going to have the ordinary stuff, and that's where we really need to go, what we can and can't do about them. The types we're going to talk about, we're going to call form factor. Form factor basically describes the shape, the size, the kind of things that are on it. The chipset's going to be the thing that supports all of that feature. The chipset is going to be the thing that helps between the operating system and the hardware itself. We're going to have a driver set for Windows, obviously, and that's based on the chipset so that it integrates with Windows. Learn how to use and set up the BIOS and physical jumpers to configure motherboard. Physical jumpers you may or may not see, quite honestly. The one that you will see, and we'll talk about passwords, you can password protect your BIOS. What happens if you forget the password for your password protected BIOS? Uh-oh. The rescue disk, what is the rescue disk going to do? You can't get past the BIOS. You can't get past the BIOS and no booting, no nothing. It's there. It's a door stop. It wouldn't keep it from starting. Rescue disks usually rescue the operating systems on the hard drive and not the BIOS itself, although you can do that. That's one of the jumpers that you would use. There is a jumper in there that will reset the BIOS for you. And when we talk about security, talk about physical security and how you keep people from booting and all that other good stuff, and you can control that through the BIOS, and it's always, well, I'll just go in and change the jumper and reset the BIOS password. Yes, you can do that. That's where physical security comes in when you start talking about, and again, we're talking about in a corporate environment. Do you have that issue at home? Probably not, unless you have some really industrious kids. Some people do. Learn how to maintain a motherboard, and this is updating the BIOS, updating the chipset. And I think what she recommends in this book is don't do it unless you absolutely need to, because there are risks involved. Typically, when you start this thing, if you have a power failure in the middle of it, you may or may not be able to rescue, back to the rescue area, rescue your BIOS. The new ones typically come with a backup copy of it that you can reinstall. The old ones didn't, and the old ones you deal with floppy, and now you do USB, and in the new ones, some of them allow you to do it through Windows, which is a lot more efficient, a lot safer. But once, if it gets through there, you may have created yourself a doorstop. Yes?
My grandmother has it's from a gaming company, but she's got the domestic edition of her computer. Her motherboard has a BIOS set up, just like a regular BIOS. And then she's got a BIOS 2, so if she wanted to change settings, she went into 2. It would test it before actually applied it to the regular.
Yeah, and the 2 is like the backup. You can, some of them do that. The backups, in case it is, and they've gotten a lot better with BIOSes. You probably don't remember, although Derek may. In the older days, when you went into the BIOS, right now you put a hard drive in, it just finds the hard drive. At one time, you had to define the architecture of the hard drive. You don't have to do that anymore. So the BIOSes have gotten much, much, much better and much easier to control, plug and play. What makes a system plug and play? You're going to have a plug and play BIOS, a plug and play device, and a plug and play operating system. So those three elements are required for that.
I have a question.
Uh-huh.
I've seen on the router's BIOS that you can turn plug and play on and off. Does that affect anything?
That's universal plug and play.
So
that's detectability kind of thing, yeah. And if you want to turn that on and off, you probably want to go read about that before you actually affect it. When it first came out, it had some real security threats. So you may want to do a little research in that one. That's not plug and play in this sort of thing. Router BIOS, a router really doesn't have a whole lot of peripherals associated with it, does it? Like none. So it doesn't need to be plug and play. What do you add to it? What do you add to? You add hardware to it, but the hardware is automatically supported when you add it in there. It's not a plug and play sort of system in the sense that you're thinking about plug and play with the operating systems. Learn how to select, install, and replace a motherboard. Typically, when you replace a motherboard, you're replacing most of the components, and what you're really doing, opinion, is reusing the case. Because if you replace the motherboard in today's world, you basically replaced everything. You may recycle a processor, but then you've got to be sure you got a motherboard that supports that processor. But everything else, most of the other peripherals, except again your gaming guys with your high-powered video, and that's really the additional item in it that you put on the machine other than what's on the motherboard. Everything else is usually supported by the motherboard. Other than that, then you really have changed the whole system when you do these things. Most complicated component on the computer, it's the thing that holds all the other devices, and usually you have this, why they call it the motherboard, because the mother and her children and all that other good stuff. But the motherboard is the thing that the processor goes on. If we have expansion slots, the expansion slots go on, that the memory goes on, that the devices that are supported on it are there, USB, keyboard BIOS, and that the keyboard BIOSes are now, I think, incorporated mostly in the chipset itself when we do those things. And when you build, and you talked about building a machine, right?
I have all my parts now.
Yeah, all your parts sitting there. What was the first thing that you looked at?
First thing?
Mm-hmm.
A tower.
A tower?
Something that would have a lot of air.
Something that had a lot of air, but what about for the processing capability? What was the first thing that you looked at? Motherboard. And you want a motherboard, what kind of processors are going to support, what kind of speeds are going to support, what kind of peripheral components will it support. Processor and then the motherboard that goes along with it, and they go hand in hand.
Yeah.
They really do, don't they? Go hand in hand with this thing, so it's going to be one of the first things we're going to consider. Consider the form factor, the processor, socket, and chipset. The chipset, again, is it's a set of chips, and that's the way they defined it, a set of chips that supports the functionality of the motherboard itself. Bus is the number of bus slots. The bus is the number of slots. What kind of expansion capability does it have? What are we going to put on it? Are you going to use one big, powerful video card, or are you going to have a couple video cards? I mean, what kind of things do you want to do with it? Other connector slots and ports. What's supported on the motherboard? And again, when we go back to what we're going to use in business, we don't need typically the high-powered add-on. Yes?
Say you work for a company that was here, like the banking system stuff.
Mm-hmm.
Will there be any instances in the business aspects that will run into SLI video stuff and anything like that?
I doubt that, no. And not unless you get into somebody that's doing graphic production sort of thing.
You know, like up front when that computer does a lot of that network monitoring stuff?
That's just a regular video card. Actually, that's not even a regular video card. Well, it is a regular video card. Oh, that's a television.
Is that an onboard video card? Or is that...
No, it's an HDMI connection. Well, it's an HDMI connection, yeah, off of the video. Most of the onboard video, unless you're doing high-power graphics, the onboard video is going to be sufficient for about everything that you're going to do. And that's where we're going with most of this stuff. The connectors, the slots. The form factor is the shape and the size of the system itself. The form factor is the motherboard size, features compatible with the power supplies. Power supplies, and you look at the power supplies, we know that there are several different types of plugs. We have the 20-pin, the 24-pin, and the 28-pin.
Yeah.
Molex, what do you need for your peripherals, what supports it, and that is, again, part of the motherboard form factor. Power supply cases, where do the screws go in? You talked about the case. That was one of the first things you want, a big case. Does the case support, and most cases actually support most motherboards. Many cases at least have multiple capabilities, and they'll be marked with what form factor where you put the standoffs in, the post standoffs in.
I bought the case, ordered this motherboard, and the screw holes didn't line up.
Screw holes didn't line up because the form factor was different from the case. The case didn't support that particular form factor. So that's one of the things that you do have to consider when you do these things. The most popular, the ATX, the micro ATX, and the mini ATX. The ATX, there is a BTX, and we talked about it, I think, last time. The BTX, everything is parallel. It actually is better for heat dissipation, for airflow across it. The ATX, the typical physical first look, the memory slots and the expansion slots will be perpendicular to each other, which could affect airflow, may not. The other ones, the micro and the mini, same basic construction, fewer expansion slots, and they've got pictures in the book, fewer expansion slots, but they're going to be smaller. The size is going to be one of these things. The mini is smaller than the micro, which I think is kind of odd, don't you? Because usually goes mini micro, but this goes micro mini, also known as ITX. And again, if you want to see one, take a look at that monitor as you go out the back. That's got a, I think that one is actually the micro. It's not the mini board. And it's kind of interesting just to see how small a device you can put processing power on. And that's running, not a whole lot, but it's running that huge big monitor you talk about onboard video. It's running that whatever size that touch screen is back there. That's onboard. That's the onboard video. Examples of following slides. Examples of form factors. So we have the mini ATX, and in this one, you notice the heatsink takes up a huge part of the motherboard itself. The heatsink. I'm sorry.
I'm sorry, I interrupted you. I didn't mean to interrupt.
Go.
I was just saying, is that covering the processor?
Yes, that's covering the processor for heat dissipation. When we talk about, they're going to have some pictures here. We can talk about North Bridge, South Bridge. The really high, and we've gone away from that to a hub, so we'll look at both the sorts of constructions there. But in the machines that have a powerful North Bridge, you'll have two heat sinks. You'll have a heat sink on top of the North Bridge as well as a heat sink on top of the processor. Heat dissipation is the real killer of these things. What I think is kind of interesting is you see these, and I just watched. The reason I was watching a TV show last night, air conditioning was out, and it was 100 degrees outside, and the inside's going crazy. When you do that, what's that going to do to your computers?
The heat from outside?
Heat from outside, just heat in general.
Yeah, the light raises the heat.
The general rule of thumb is, if you're uncomfortable, and I would be at 90 degrees, your computer's uncomfortable. So that's just kind of a rule of thumb. Nothing really hard and fast about that.
Me, in the summer months, I'd turn it off when I wasn't using it.
Turn it off when you're not using it. Yeah, keep it in an air-conditioned space. Watch out for south-exposed rooms with direct sunlight on them. All of those things can cause you issues. And heat problems, lack of heat dissipation is typically going to be manifest, going to show up as erratic performance. Sometimes it does, sometimes it doesn't.
That's where it crashes my laptop.
So, yeah, well, laptops really don't have, I don't think, great heat flow or great airflow through them.
The new company, it was not new, MSI, hasn't created their own new laptop cooling system where it comes... A lot of people have. We got this cooling pad and all the other things that you can buy to help it. But as long as you keep them out of the direct sunlight, is that what got you is direct...
No.
Just heat in general?
No, my CPU's overclocked for one.
Overclock CPU in the laptop. No, such a great idea.
And my hard drive RPM is higher than required.
Yeah. So it was generating more heat. Than it was had the capability to dissipate. And they don't really have the ability to put case fans in and things like that. They're kind of what you see is what you get. Very little ability to modify, and we'll get to laptops later, take them apart and look at them.
The hard drive shot in that one, but I've dropped it like 20,000 times, but I'm going to bring it in so we can...
Bring it, we'll take it apart, yeah, when we get to absolutely. But yeah, this is the big heat sink, heat shunt. They call them heat sinks, and we'll call them heat sinks. Heat sinks are supposed to be permanent, and these are removable. Heat shunts are removable. They do the same thing. They dissipate heat. But that's what that is. And then we have all of the different components that are supported by the motherboard. That's all going to be part of the chipset. We've got sound. We got a NIC. We've got some USBs. Got VGA. Got a serial port. Got some more USBs, and then we've got a mini DIN over here. We have the extra plug here for the system that we talk about to come off of the power supply when we talk about the 20-pin plus the 4-pin, and that's to support the processor. And with some serial ATA looks like over here. So this motherboard has lots of capability, lots of support on it. Chipset, BIOS is the thing that supports all that stuff that's built onto the motherboard. This is in the book. You can take a look at it. The sizes for each of these things, 12 inches by 9.6, 9.6 by 9.6. The micro, again, the micro is bigger than the mini 6.7 by 6.7. I guess that we could take a ruler back there and measure that motherboard and see what is the micro and the mini. Maybe we'll do that. Flex ATX, the BTX, micro, Pico. Pico, up to 8 inches wide, and then the NLX used in low-end systems. A number of different ways to do these things.
The one I'm bringing in has 8 expansion slots in it.
Yeah, the number of expansion slots, if you look over here on the boards, the old systems tended to have lots of expansion slots. Excuse me, but you'll notice the reason it has lots of expansion slots because if you look at the back of the motherboard, you see that there are no ports except for probably a keyboard. There were some systems really early. I remember that you actually had to put an expansion card in, put a mouse on it. I mean, back in the DOS days, did you need a mouse for DOS? Didn't care. DOS didn't use that. So as we have put more functionality onto the motherboard, the number of expansion slots typically have decreased. Because what do you actually have? What would you actually need, other than I'll go back to the gamers and we're going to exempt the high-powered video card. What do you actually need to add to a computer today? Really not. Maybe a TV tuner if you want to watch, if you want to do that kind of stuff. But everything that you need, functionality, Wi-Fi. Many of these come with Wi-Fi built in. You might Wi-Fi something. You might if you're going to use a desktop on a wireless network. And I don't know. I don't think you can buy a laptop without Wi-Fi anymore, can you?
You can buy ones that are a little more secure, but...
A little more secure, but I'm saying about without Wi-Fi. Most of them come with Wi-Fi.
These ones I'm thinking about are satellite only.
Yeah, but that's a special function. If you go over to Best Buy and say, "Hey, I want to buy a laptop, but I don't want a wireless. I don't want a wireless NIC in it."
They have one computer there. It's satellite only.
One satellite only, but that's a special use machine. Satellite only, that would be wireless.
It is.
Not 802.11, but it would be wireless. The processor socket, and you said that was the first thing you wanted, the processor, and that typically you go one way or the other, either motherboard and then processor, or processor and then motherboard. The two major manufacturers, Intel and AMD, I think even Apple's gone to Intel now. Motorola used to make their processors, so the old ones.
That are on their way?
I think there may be some odd ones out there, but typically no. There used to be like 4 major manufacturers. There's never been a ton of them.
I always figure IBM would have their own just as big.
No, IBM is really not into the small computer business. IBM's into mainframes. They don't even own we have the IBM. We call them IBM PCs. They don't make PCs. They sold their PC business to Lenovo. So Lenovo And if Room 109's got a bunch of Lenovo machines. Lenovo is the manufacturer, was the manufacturer when IBM owned them, and IBM just sold out the whole thing to them. So they don't even have that. They're a mainframe company. They're really a service company. It's an IBM standard because they actually did make them back when we talked about either. Well, we actually call it PC standard now, I think, instead of IBM standard. Sockets for the Intel processor, several Titanium and Xeon processors designed for servers. AMD or Intel, does it make a whole lot of difference? I don't know. I don't really think so. They're both pretty reliable. And what you have in these things, socket processors are different methods, a pin grid array and land grid array. Pin grid array is kind of an older system, and that's where it has pins on the processors. The old machines that we'll be taking apart will be PGA, pin grid array. Land grid array basically reverses the process. You have receptacles or indentations on the socket itself, and then a place for the processor to sit on top of it. The pin grid array, the issue was it's easy to bend the pins. And once you bend the pins, it's a real pain to try to straighten them out again. Actually, we used to have pin straighteners that we could use for these things. So all that stuff, as we progress, things become better. The slot 1 was kind of an attempt to get away from that. It didn't work all that well. Land grid array uses lands or pads rather than pins on the socket, and then it has a receptacle component on the processor itself to get away from the pins. The flip chip land grid array, the chips flip so that the top of the chip is on the bottom and it makes contact with the socket. I mean, it's just a manufacturing process when we do those things. Staggered pin grid array, and you'll go on and on and on. Ball pin grid array, so it squeezes more they stagger more pins into a smaller space. Again, pins are easily bent. Before the ZIF, and I think they'll talk about that in a minute, but the ZIF, the zero insertion force, with the little levers on them that just kind of opens and lets you take them out and drop them in, you actually had to insert these things with pressure, and that's when you could really bend them. I had a group one time, we could take it apart and look at it. Don't take anything out of the computer. Oh, no, we didn't take anything out of the computer except the guy that did take something out of the computer. Oh, no, I didn't take anything out. Took the processor out, put it back in, 180 or 90 degrees out. Fortunately, didn't destroy it, but you need to pay attention to those things. And back to what we talked about, pin 1. Pin 1s are always going to be marked, and you need to be sure that you align the pin 1s with all of these things. This is a picture. The plastic cover protects the socket when it's not in use, and this is a land grid array, LGA 775. LGA land grid array, the 775's got 775 pins. And as we go on, you get more and more and more pins, more and more transistors on the CPUs themselves, which means that we have more and more problem with heat dissipation. And the heat sinks become bigger and bigger and bigger, and the fans become bigger and bigger and bigger, and noisier and noisier and noisier, although these machines are not very noisy.
So the LGA is the higher the number, the
more pins, yeah. So yeah, well, the number is actually the number of pins that are on the processor.
Mine's 2011.
So it's got 2011 pins,
Okay.
which is, I mean, that's where we keep going. And as you put more capability on the processor, you're going to have more pins, more transistors, more pins. The ZIF, the zero insertion force, all the processor sockets now, the lever on the side lifts up, and you can just take it in and out without any force. And that was a big advantage when that started out. AMD uses the PGA socket architecture for the desktops. PGA pin grid array. This is a list, and again, this is in the book. You can take a look at it for the AMD sockets. What's on those and the names of them? The Phenoms, Athlon, Sempron. How the name goes with the socket, with the processor socket. Athlon 64, AM2 plus socket they're getting ready to insert this thing. The lever here for the zero insertion force up, drop it in. If it doesn't drop in cleanly, it's not aligned. Should be able to just drop those things and they will go down flat, and then you use the lever to lock the processor in place. And you have to match, obviously, the motherboard and the socket. The chipset, set of chips, that's a really good name, right, for chipset, a set of chips, that work with the processor to collectively control the memory, the motherboard buses, and some peripherals. So what it really does is what kind of features are available on the motherboard itself. Chipsets occasionally get upgraded, and that's what BIOS upgrades are for. And I think you'll find that she says in the book that unless you got a really good reason, there's a feature that you want to use that's not available with the current version, don't take the risk, because there is some risk involved in upgrading the chips of the BIOS is what we're really talking about as you upgrade these things. The manufacturers, and there are more manufacturers for chipsets than there are motherboards, Intel, AMD, NVIDIA, SIS, and VIA. Intel has a bunch of them, and many people say, hey, they probably know their chipsets better than anybody else. So Intel, or know their processors better than anybody else, so their chipsets may be more supportive of the Intel processors, and AMD, the same thing, although NVIDIA and the rest of them seem to do a really good job of supporting the processing capability, processors of these things. The chipsets, the North Bridge, South Bridge, is an older version, and I think we've gone away from that, and we use Sand Bridge, that's the terms that we use now, and Sandy Bridge.
Sandy Bridge is moving out.
And they're all changed, but they changed what the concept, the architecture of what goes on, and as you go from one to the other, it's basically how much or what actually operates on the high-speed bus. We're going to have a high-speed bus and a low-speed bus. The high-speed bus is going to be the North Bridge, the fast end, the South Bridge, the low end. And when we go to the hub concept, we don't have a north and a south. We have things that are directly connected to the processor and things that are on a bus itself. So when we look at this thing, we have the processor connected to everything, the FSB, the front side bus on this, the primary PCIe slot for the video card, so the video goes into and we want that to be there, right? The video goes into the North Bridge, and RAM goes into the North Bridge. Everything else down here, the I/O controller for the South Bridge, the other PCIe cards, we have the one that's generally the primary is going to be designated for video. That's the one that's going to go into the high-speed bus. The other PCIe slots are going to go into the South Bridge. So USB sound, basically everything except memory and video go into the lower speed bus. The higher speed bus, bigger connection to the processor itself. Okay, so Intel chipsets, the i7 and the X58, referred to as the NEOLM, contain memory controller and a quick path interconnect technology. 16 lanes for data packets. 16 lanes, and I think there's like four bits per lane, so that works out pretty good to 64-bit architecture. So 16 lanes, 4 bits per lane when we do these things. Sandy Bridge, memory and graphics controllers in the processor. The second generation i7 is an example. The motherboard uses DDR3 memory. So as we go through these things, let's go up here. A picture of this, we have the South Bridge, the PCI version, the graphics, support for multi-card configurations are in this thing up to 36 lanes. So we have the North Bridge, the processor, DDR3, the DDR3 memory is directly in the processor. And as we progress in the architecture, you move the graphics up to where it actually goes directly into the processor. So we have the hub arrangement here. High-speed ports, PCI Express, the X1 or times 1 is a single lane PCIe slot. Ivy Bridge, the third generation, less power, more transistors in a smaller place, perform better than the earlier, uses a single platform controller hub, which they didn't put a picture of in this thing. I think there's a picture of it. No, there's not in the book. I'll look to see if there was one that I could get. The AMD chipsets, again, you can look at those things, and you can look at tables usually are a better way to do this than try to just say, oh, this one, this one, this one. You're not going to remember any of that stuff. There are some specifics that when you go through question banks that they may want you to know for the A-plus test, but what are you going to do? You're going to use what you need to support what the company needs. If you're going to go, if you wanted a gaming computer, you're going to go into the high-end stuff. For a regular machine, but honestly, what they do here is they go to Dell and find something that's kind of pretty good, a pretty good price. Do we in this school need the latest and the greatest? Everybody, oh yeah, we want to go to the latest and the greatest, and businesses don't do that. A business will upgrade when it's profitable. If it's not profitable, if there's not something that the current generation's not doing or become unsupportable, until that happens, they're going to keep using what they've got, as long as it supports the business.
Government's a perfect example.
What is?
Government.
Government, oh yeah. Oh yes, they are.
These are afraid of people.
And in some cases, that's absolutely true. And here's your SLI. If you're playing a gaming computer that uses 2 video cards, that's when you get to the SLI. 4 video cards, multiple video cards, but doing 2 cards, I use 2 monitors at home. And what I did was just go get a video card that's got 2 plugs on it, so that you can go one to the other. You can put multiple video cards. What I'm using for this, and you notice that this is a mirror. This has just got a, I think this one just got a splitter on it. Some of the machines have 2 video cards, the dual monitors that you have here. These particular motherboards came with 2 video connectors on it, so it worked out well. The big screens use the fancy one, the new upgraded video connector, I think, and I'm not sure exactly which one it's connected to, and the small one's connected to the VGA port. It has both of them on, both of it on the motherboard. Buses. A bus is just a bundle of wires. When you look on the back of a motherboard or the front of a motherboard, you see traces, you see things that look like little wires inside the motherboard itself. Those are the buses. The connectivity between the different components, usually going to the processor. Memory to processor is the bus that we're really worried about. Power control signals, memory addresses, and data are the things that are on the buses. Only 2 states on and off because we use binary, and that's really handy, on and off, 0 and 1. As you learn as you go through all of these things, that binary makes it easier, because now all we have to do is be able to count to 2, multiply by 2, and those kinds of things, so we don't have to do any high-powered math in these things. The data path size is the width of the data bus. The 8-bit bus has 8 wires or lines, and that's what, when we go from a 32-bit to a 64-bit bus, without changing the processor speed, we've actually doubled the computing capability of the computer, because it can send twice as much information in one clock cycle. And when you talk about processors, we talk about speed, right? So many gigahertz, and I have no clue what we're up to now, probably 3 or 4 gigahertz?
AMD has a 5 gigahertz.
5 gigahertz. Well, I'm going to use something simple because it's easy arithmetic. 1 gigahertz. What does, if I say a processor is a 1 gigahertz processor, what does that mean? Really?
1 gigabyte.
1 gigabyte, no, it has nothing to do with size, it has to do with speed. It means that every billionth of a second the computer's doing something. The machines are set up kind of like a metronome. You've seen that either at a concert or in a music class or on TV or whatever else that keeps the beat. The clock's what keeps the beat of the computer. So the clock in a gigahertz, 5 gigahertz would be a lot more. I use the 1 gigahertz because I can divide that. Every billionth of a second, the computer's doing something. I can't even do something in a second. I don't know about you. That's pretty fast. And what it does is says, yes, you can do this. Some things take more than 1 clock cycle, obviously. If you have particularly slow peripherals, the processor's got a wait on them, and then it goes into what's called wait states for waiting for the slower peripherals to respond. And that's why in the architecture we talk about, the closer we get the video, in particular video is one of the slow things for us, the video and the memory closer to the processor itself, the faster the machine can run, because you don't have to worry about the delays in the bus itself. You're not really using the bus. So the clock rate is the metronomes. Every time the clock does a clock rate. Yeah, every time the clock does a click, then the CPU does something. The computer does something. So the speed of the processor obviously affects how fast the computer runs. But more than that, possibly more than that, because they don't usually double them. The bus architecture, 32, 64, 8. We go back to 8, 16, 32, 64, and then 128 will be the next thing probably that we're going to have, because you've got, since it's binary twos, we need to go in powers of 2 as we do these things, just like you do in you guys had, just like you do the subnetting, right? When we do these things. So the bus line, 0, no voltage, the binary component of these things, the letter A on an 8-bit line is going to be, this represents in binary the letter A. So how much information can we send is a function of how big's the bus. And sometimes you may hear that called the word size. How much can it send at any one time? Activates the motherboard. I think we've already done this discussion. The clock, speed of memory, the front side bus, or the component is measured in hertz, which is a cycle per second. Actually, it's going to be measured in gigahertz, a billion cycles per second, a billion things every second. So it does something every billionth of a second. That's why I use the 1 billion. It's easy. The arithmetic's easy on that one. You can have more than one bus, and many of them do have more than one bus. The data path, the serial lanes, the bus frequency, and again, this is a chart that's in the book that you can take a look at. This is for the AGP standard is summarized here, each of these things. PCI Express, the thing that we use now, local video, serial line up to 32 lanes, address line up to 32 lanes, the bus speed 2.5 gig, and you notice that it is by far and away the faster of all of these. We go from 2.5 down to the PCI Express version 1 is 1.25 gigs. So the version 2, we've doubled the frequency. So that means that twice as often it can do something. 500 megabytes per second lane in each direction, per second per lane in each direction. So that's a lot of information going back and forth. And video's gotten more and more complex. We want more and more and more of it, because I'm visual, most of us are visual, and that's where the video comes in, so that we can see those things and do those things and demonstrate those things. So it is something that becomes more and more. And that's typically when you go Windows from one thing to the next thing to the next thing to the next thing, the one item that becomes the biggest issue is going to be the video drivers that may or may not work from one to the other. Conventional PCI, first was 32 bits, 5 volts, then we have 64 bits, 3.3 volts. And when you look at the cards, and they've got pictures, I don't know if they put the pictures in here or not, you've got voltage slots, voltage notches on the PCI, so that you can't put a 3.3 volt card in a 5 volt slot. Some of them will go in either slot, so they'll be notched at both ends when you look at those things. Yeah, they do have it here. So we have the 32-bit PCI slot with the 5 volt notch and the 3.3 volt notch, so that you can't put the wrong card in the wrong slot when you do these things. The 64-bit notched a little bit differently, not a whole lot differently, but a little bit when you look at these things, and some of them have universal ones. Buses and expansion slots, nice picture here of what goes on. We've got a number of different, we've got a 64-bit, 32-bit PCI, It looks like some AGP in this thing. Memory. The north bridge is going to be the thing over here with the smaller heat sink. The processor is going to be the one with the enormous heat sink here. One of the things that you may run into if your machine starts acting erratically, and we have a number of older computers around here where the capacitors just kind of explode. The capacitors are on here to maintain a steady voltage. And as they start popping, and you can tell because they get oil all over them, you may want to look at, going to have to replace this motherboard pretty soon because they become erratic. And this one's got 2 processor slots, so it's a dual processor system. 64-bit, latest revision of the PCI X3. All revisions are backward compatible to PCI X on this thing. And again, 2 processors, 2 physical processors are available in here. Now we get processors with cores, with dual core, quad core. Better use, I think, of space, probably of space, because to get more processing power, we only need 1 slot for those things to go into, the number of cores. The server that we run the virtual machines on, I think, is it's got 16 cores total, 2 physical processors with 8 cores each. So you can move on up into those worlds.
Mine at home is 12 cores.
12 cores?
6
Yeah.
hyper-threaded.
Yeah, and they go on and on and on and on and on. Heat, again, becomes the real issue. Can you dissipate the heat? And you said you had case fans and all sorts of stuff on that. But you've got to have the coolant. Liquid coolant, that'll do it. Absolutely. PCI Express, no backward compatibility. And it says expected to replace, and it is replacing the PCI. It is a much better standard, a much faster standard, and probably a lot more compatibility when you do those things. Here we have pictures of a PCI, a 16-lane here, and a 4-lane compared to the conventional PCI. And then we have a couple of, well, at least 2 PCI single-lane slots. Oh, here's the other one. Yeah, there's 2 PCI single-lane slots in this thing. It's kind of hard to see up here with the black on the black. But motherboard PCI Express is where we're going for most components now. This is called a riser card. And we have one machine back here that has one in it. If you have the really flat, in the good old days, when you had expansion slots, a really flat desktop, the cases might not be tall enough for the expansion cards to go into. So what they did was basically put it in sideways. What you really did with this riser card is you plugged the motherboard into the riser card. And it kind of was on it sideways, backwards, upside down sort of arrangement.
Support the weight so that it didn't have any cards?
They didn't really have it. Well, you can always do a support on that. Everything was sideways, so it really wasn't an issue with them. You'll see when we take it apart. You'll see that it actually does plug in that way, which is kind of an odd arrangement. But there are some older systems, and these are really older systems that you may or may not see that have that, because we don't have expansion cards anymore. Really, realistically. And the expansion cards have gotten smaller. If you look at some of these old cards that are hanging around here, they're big. They're really big. If you look at the new ones, they've got much smaller. And everything has become anyways. Huh?
You can go that far.
I'm talking about, well, some of those are not as old as others, but some of the really old cards around, they become pretty big size. There are all different kinds of cards over there, but they're pretty big, and they wouldn't fit into. A lot of them are their own bus type. They just wouldn't fit into the cases, because if you look at the cases of the machines that are in here, these are really not very tall cases. So when you get an expansion card, if you wanted to put an expansion card in it, you've got to get something that fits into the case as well as does what you want it to do. And we've had that before years ago where you get a card, and that's where you started going with a tower arrangement because it had a lot more space inside it. But we have gotten cards that wouldn't fit into the cases.
I did that. My card charger and mine are 6.5 inches wide and 12 inches long.
Yep. So that's why. I mean, some of them are really big, so will they fit into the case? And that's one of the considerations for all of these things that you do. Will it fit? Will it work? So lots of things that need to be considered: the right bus size, the right physical size, the right voltage, do I have that type of expansion? Yes.
Question I had before you got past it is, does card drag damage the card? Like where the weight isn't being supported and it just kind of hangs off?
It really shouldn't be hanging off. Most of them, well, you got it sideways?
I mean, it's plugged in.
Most of them have.
Like
Many of them have, yeah, but most, they shouldn't be. It shouldn't be sagging. If it's that sort of situation, they're typically going to have a lock on it that keeps it in place at the base of the card. And you need to be sure that lock is that thing is locked.
You're talking about the lock for the PCI line?
Yeah,
Yeah, it's locked.
Yeah, that shouldn't be a
problem.
problem.
The outside part, it kind of drags.
Yeah, that shouldn't be. Yeah, that shouldn't be a big issue. It should be supported by the structure of the case from the outside.
You can't get a screw in there. I've tried.
Well, see, that's one you need to work on a little bit then, because it should be supported on the case. Eventually, will it do damage? Yeah, it could. Will it? You can't guarantee it, but there's certainly a possibility there. Onboard ports and connectors. We've seen those, done those. Chipset, BIOS, those sorts of things is what we really want there. The IO shield is a plate on the computer, on the outside of the computer. And internal connectors, the FireWire, floppy drive, yeah. When was the last time you saw something come with a floppy drive? The machines you're going to be working on, the old ones back here are going to have them, but floppies are kind of become a thing of the past. You may or may not ever see one of those. SCSI, USB, FireWire, all those different connections on the inside of how do we connect to what you're really going to see mostly today, I think, is a serial ATA and for the connectors, and then the power connectors that go with those. Motherboard settings, enable and disable a connector, control security features, control what happens with the PC at the first boot. I want to look at a simple BIOS on a virtual machine, and they are very simple BIOSes. And one of the activities, I think, for Chapter 4 is that you go in and investigate the BIOS. If we can get into these machines have a relatively complex BIOS. It's a good thing to look at. The simple BIOS is, they don't do a whole lot. What's the boot order? Those kinds of things. What happens when you push the power button? The more complex BIOS is what can't you do. One of the things that we do with our BIOSes is they turn on the computers every morning, which you may want to do in a business. That I think it's at 7 o'clock. I don't know what he's got these set for, but because when you come in, the computers are on, right? And you didn't turn it on, and they get shut down every night. So we shut them down with a policy, a Windows policy, does security scan updates and those sorts of things, and then in the morning the BIOS turns them on at whatever time you specify. I do that at home because my wife said, I get tired of waiting for the computer to come on. So I just set the BIOS to come on every day at 6 o'clock so that it's up and running and stable by the time she gets to it. Control what happens when the PC first boots. We do those things. Dip switches, jumpers, and CMOS RAM. Dip switches, even the book says, you're probably never going to see one of these things. Dip switches are just 0-1 switches. Jumpers, you're going to see a few, not very many. The older machines that we'll start with, you'll see more of those. The jumpers, just 2 posts that you make a connection. Or I'll make a connection. It's kind of like a light switch. Well, the dip switches are what would be more like a light switch, I guess, on or off. The jumpers, we use a physical jumper to turn that particular component on or off. Most of the stuff's now going to be controlled by the CMOS RAM, and the CMOS RAM is going to be maintained, held by a CMOS battery. The batteries typically don't discharge unless you leave it off for an eternity anymore. Not always been the case, but they do actually recharge now while there is power to the computer. So if you turn the power off for a long period of time, the battery may discharge. You may have to replace it. If you do have to replace it, it's one of those little round batteries. Just be sure you get the same one. Yes?
I noticed a lot on the newer motherboards that they stay on when your computer's off. The motherboards.
There is power to the bus, and you're going to typically have a power switch in the back. They kind of stay on, and that's for things like updating, that you can turn it off, and we've got a packet, and they call it a magic packet, that you can send to it and say, hey, wake up and get updated. So the bus is active or can receive signals. And there are things that when you turn it off and that stays on, if you have it configured to do things, it may actually wake up in the middle of the night, do something, and then shut back down. So that's why that power does stay on the bus. You have to be careful about that when you're working on them. Be sure that it's turned off. Actually, when you're working on them, unplug it and wait for usually you're going to have an LED that is on, that's lit when there is power on the bus. Wait till that power totally discharges before you start working on it. Because it'll probably be discharged by the time you get the case cover off, but be sure it is discharged before you start working on these things. About everything's in the CMOS RAM. Different manufacturers have different key combinations to get into the CMOS. And generally today it's going to tell you. They used to try to hide that, and it was hard to find how you get into the CMOS, but it's much easier now. Jumpers are the two small posts, and picture here, just the jumpers, all it is two small posts, and you put the cover over it, and it makes the connection. It's a piece of. The only thing that's in that is a plastic cover, and then here's just a piece of wire that goes across it that actually makes a connection between those jumpers. Access, the key combination varies by manufacturer. On these, I think it'll tell you when you start up to press the F12 or F2. I've forgotten which one it is. It's one of those. I think that the one to go into setup, I think, is F2. And F12 is the boot sequence on these. But when you get there, the configuration, what can we do with the setup? Change the boot sequence, and they've got a list of what's available. What's available is going to be a function of the chipset that's on the machine itself. Configure onboard, enable, disable, view the hard drive, intrusion detection, all sorts of things. Power on passwords. This is something that you can protect if you have an issue, you can protect your computer with, is a startup password that somebody has to put the password in order for the BIOS to activate. That would be in a pretty secure environment. But the issue here becomes physical security. We can go in and we know how to reset the BIOS password. We'll reset all the passwords so that you can clear those passwords if you know how to do that. LoJack started out as a car technology, keep people from stealing your car. And they kind of do that in iPads and iPhones, right? Find My iPhone. Where that, if somebody turns it on, it'll locate it, but it has to be on the Internet. It has to be turned on. It has to connect to the Internet. This is a similar thing, and I think all of them, even the Androids have that now too, don't they? That you can do those things. What this is a technology that goes into your laptop or your desktop. Somebody steals it, connects it to the Internet. You can locate the telephone. I actually had a guy that worked well for him one time. He lost his phone. And he went online to find my whatever it was. I think his was an Android device, and it showed him where it was. And somebody actually had found the phone, and he managed to get it back, which was a good deal for him. Drive encryption and drive password protection. Microsoft has drive encryption that's available, and when we do that, the BIOS has a TPM module where a certificate is stored, so that if the hard drive gets stolen and put in another machine, it's encrypted and you can't read the information. The problem with that is, if your hardware fails, and you put a new set of hardware on that hard drive, it doesn't have the key. It doesn't have the certificate, so the information remains encrypted. Any time you get encryption keys, make a backup. Back it up. Put it on a flash drive, something, and put it away. Just keep it stored someplace. So that if that happens, you can restore the original certificate, and then everything should work. Same thing with encryption keys or signing keys. Any kind of key that you get for your email goes into your profile on that machine. It's a great thing because you have to be on that computer to physically access it, to sign it. But if your profile gets corrupted, guess what? So is that signing or encryption key. So make a copy of those things. And Windows now has gotten a lot smarter when you do that. Say, oh, you may want to make a copy of this. Trusted Platform Module chip is the one for the BitLocker encryption. If you want to use BitLocker, and this is more Microsoft specific, if you want to use BitLocker and you don't have one, you can actually put the encryption key on a USB drive, and you have to put the USB drive in before it can read the hard drive, because that's where the encryption key is. But the TPM module holds the encryption key for the hard drive when you enable BitLocker. That means that if somebody steals your hard drive and puts it in another machine, it's encrypted, and they can't get to the information, which would save a whole lot of trouble. Would you get involved with when they lost all the veterans records, the VA records? Yeah, me too. Something like that would have prevented that. And people losing flash drives with all this fancy information on it. There is a BitLocker to go that you can actually encrypt a flash drive also.
Lucky for me, I still have hard copies.
Still?
Records.
Huh?
I still have the hard copies of my records.
Still have the hard copy? Yeah. The issue with that one was they were afraid that they'd lost our Social Security numbers, which was a big deal. As it wound up, they really didn't. There was a couple of kids stole the laptop, and they wanted the $200 for it or whatever they could get at the pawn shop. They eventually did find them, and they weren't trying to sell the record or compromise the information. They didn't know what they had. Virtualization, and they will ask a little bit about virtualization. What virtualization does is if we have a single computer, we install a single operating system that uses the hardware. That's what's on these desktops, right? In virtualization, we run the operating system multiple times, and it shares the same set of hardware, which is a better deal than dual boots. Dual boots used to be what we used a lot if we needed a couple of different things, but you can only run one operating system at a time. In virtualization, you can run multiple operating systems, and they don't have to be the same one. We can run a Windows and a Linux on the same set of hardware, using some sort of a hyperterminal in order to do those. Maintaining, update the flash, replace the CMOS batteries. Nothing really mystical there, I don't think. Update the motherboard drivers, small programs, and these are all going to be from the manufacturer. When you put in a motherboard, you're probably going to get a bundle of CD drivers. The operating systems themselves are getting a lot smarter, and they can frequently find those things for us. Flashing the BIOS, this is one we talked about early on. Yes, if you need to do that, but keep in mind that there is some risk involved here, particularly if there is a power failure. And you can never really predict. I guess the thing is, you don't want to do that in a thunderstorm, but you can never really predict when there's going to be a power failure. The methods, the Express BIOS update, that's the one that installs through Windows. You can flash it through a USB drive. A bootable CD, recovery from a failed update, I think that's what Jeremy was talking about earlier. You have the second. If it fails, then you can go back to the original and have it put in. That's something that's really handy now that they've done, or test what would happen to it to see if you really mess something up. And that's a great idea as they do these motherboards. High-end motherboards, good motherboards, new motherboards. As we go further into the systems, as more development happens, they get a lot smarter about what if this happens, what if that happens, sort of arrangements. And this is if it ain't broke, don't fix it. in the BIOS update. Unless you've got a good reason to do it, don't. Later version, and you have to be very specific. You have to be sure you got the right chipset. Be sure that the update's really an update and it's not a backdate. You need to go forward and not backward with these things. Should not be interrupted while in progress. If it does, you may have made yourself a doorstop. Placing the CMOS battery, that's just a matter of getting the right one, and most of them are all, I don't remember what they are, like a 3.5 volt battery or something like that, 1.5 volt battery. Just put the route one in there, they'll pop out, pop in. Nothing really magic about that. Installing, replacing a motherboard, the form factor, those things that we've talked about earlier on, is the correct form factor, the processor, we're going to keep the same processors. Does it support that processor? Does it fit in the case? That would be the form factor issue. The back panel, does it fit in the case? Can we get the screw into the card so that you don't have the sagging thing? And what you could do, you know, you could have something that you support the cable instead of have the cable pull the card down. Just support the cable so that it doesn't pull the card down. Just something that's not really designed into it but is functional when you do that, because you don't want to put pressure on those things if you can avoid it. The checklist is in the book, and I'm not going to read those to you. 1, 2, 3, 4. What are you going to do with these things? What they do say is follow the instructions. Some of them say put the CPU in before you put the motherboard in. Some say put the motherboard in and then put the CPU in. Do basically whatever they say. There are some that we have that make it the way that the cases are designed and the motherboards are where the components lie, make it really difficult to get things like memory in once you've got the motherboard in, because just the clearance, getting your hands into the area. Check those things out, and you may want to install some of the stuff on the motherboard before you actually put it in place physically. Add the boot order and all those other things. Observe post. Whole bunch of things that we can do there. So, motherboards, primary, function, choose processor, motherboard, whichever order you want, one or the other. Form factor, will it fit? Does it do what we want it to do? Those sorts of arrangements. The popular ones, PCI, AGP, the things that we added, the chipset, what actually gets supported on these things when we do them. Or you have questions, CMOS battery, things that you may need to replace when we do, as you go through all of this. Questions? Okay, what we have here is a simple BIOS on a virtual machine. When I go in here, the main tells me what it is. It's an AMI BIOS in the BIOS build. You can see this is really new, 22206, so it's been around a while. The system memory, how much is in it, the system time, and the system date. The system time becomes significant with Windows in Active Directory, because if the time on the computer is not correct, is not within 5 minutes of what the domain controller thinks it is, it just simply won't let you log on to the system. In the advanced, we have the IDE configuration. Primary IDE, which channel we're going to have, secondary, what's connected to what as we do these things. The floppy configuration, do we have one? And these virtual machines do have floppies. The boot setting configuration, quiet boot is disabled, boot num lock is off. I don't know about you, but I like that to be on. What that says is turn the num lock on at boot. Windows actually may change that for you. The quiet boot, it says disable displays of normal post messages, enable displays OEM logo instead of the post messages. If you want to see the post messages, leave it off. And to get from one of these to the other, I just do an escape. And then power management, APM, ACPI, Wear OS, yes, just what's there. And again, this is a very simple one. Boot's going to be the boot order. boot device priority. First it's going to go to a floppy, then to a CD, then to the hard drive. Once you get the machine configured, what you probably want it to do, if I can get it to the top, these are really weird systems. What you probably want it to do is boot to the hard drive first. That way it doesn't have to go through to check. Is there a CD involved? Is there a PXE boot? Do I need to do that? And it'll go straight to the hard drive. So after you get it configuration, so we can change the boot order here of what we want the system to do. Security, supervisor password, user password, clear the user password. We can set the passwords here if you want to have them. And then exit, when we do exit, F10, you'll notice on the right there, F10 is save and exit. If I just exit, escape, it says, do I want to discard the changes? That means that, yeah, I've gone around, looked at it, fooled around, seen what's there, and I don't know if I made any changes or not. But if I hit the escape key and say OK, then it will discard, throw away all those changes, which is kind of a safe way to do it. If I do F10, it'll save the configuration changes. And I said OK, and we're going to start back up here with the changes that I made. So this one should go directly to, shouldn't look for anything else, should go directly to the C drive. That's basically the only thing that I changed on that one, I think. With that, are there questions?